Hello everyone, welcome back to Engineering Graphics YouTube channel. Friends, in today's lecture, we are going to solve problem based on isometric projection. So the problem statement is the figure shows front view and top view of an object. Draw the isometric view. Let's now see the solution of this problem. The origin O is given at the left bottom corner. So we can consider this is the length of the object. From O, this is length, 50 mm is the height, and 60 mm is the width of an object. So total length of the object is 100 mm, length is 100 mm, width is 60 mm, and height is 50 mm. So these are the overall dimensions of this object. We know that for isometric box, we required a isometric view. We required an isometric box. So this is a three coordinate system. This is a x, this is z, this is y. Along x, for this problem, we have marked length. This is a height h and width along the y-axis. We are going to mark. Now let's see the solution of this problem. We know that this angle is 30 degree. X and y is inclined at the base is at 30 degree. Step number first, draw a horizontal line, mark a O point, take a protractor and mark 30, 90 and 30 degree angle. So mark or draw X, Y, Z axis. We have the overall dimensions of this problem. So length along this direction, this is x direction, this is x axis, z axis and y axis. This is the front view. So if you look this object from this direction, from x direction, I'll get front view in this plane. Height of the object is 60. So mark a 60 mm height from base along z. So this is height. Length is 100, and width is 60 mm, and width is 60 mm. Width is 60. Height is 50 mm. Height of this object is 50 mm. So you're wrong mark. Height is 50 mm. Now make a isometric box. Adjust a ruler along z axis. This is 60 mm. Along this axis mark 50 mm. Along this z axis also mark 50 mm and join this line, these 2 points. So we'll get a 2 planes. Adjust a roller along y-axis and complete a third plane. You can see we have completed the isometric box. For isometric box, we required length, width, and height of an object. Now this is a length, width, and height. Now we can start our problem. In the front view, we can see this full profile. This is the front view. This triangular section in the top view, you can see this triangular part is at the center of this object, and the width of this triangular part is 30 mm. Okay, and this inclined line indicates this two rectangular part. This line is slope. Okay, we can start problem from O. We can give the naming O 1, 2, 3, 4, 5, 6, 7, 8, and O. So you can draw O to one line, and its height is 20 mm from O. 20 mm height. This line is non-isometric line. We cannot directly draw this line. For that we require point number 2. जर point 2 मिळाला तर आपण ही line join करू शकतो. So this distance is 100 mm. So we can mark 6 points. This is 6 point here. 6 to 5 is again 30 mm. 6 to 5 is 30 mm. Then 30 mm, then this distance from this end, point number 3 position is 60 mm. So from this point, point 3 is at 30 mm. Then draw a vertical line from this and draw a X line. So this is point number 3. This is point number 1. So this distance is 30. 2 to 3 is 30, and this 2 to 1 distance is 30. So we can mark a point number 2. So this is point number 2. Directly join point 1 and 2. This is, you can see this is a profile. But circular part is there, half circular section is there. The circle center is at 30 mm from O. So mark a center, and the diameter of circle is given, radius 18, so diameter is 36. So from take a compass and measure 18 mm distance in your compass. It's 18 mm distance, and mark point number 7 and 8 along the length direction, and this ruler along y direction, and complete a rhombus here, same distance 18 mm distance, and mark 18 distance along a vertical line. Now complete rhombus here by using thin line. By using thin line, draw a rhombus of dimension 36 by 36. You can see. So we have made a rhombus here. Now take a, before that, these are the center midpoints of this rhombus. Now these two are the obtuse angle. Now join obtuse angle and opposite side midpoint. There are two obtuse angle, and in front of this obtuse angle there are two lines. This method is called as 4 center method. In isometric view, we cannot see a perfect circle, but circle in isometric view looks like a ellipse. Now you can see here, this is C1 center, C2 center, C3 center, and C4 center. In this problem, the upper half circle is there, so we choose C1, this is C1 center, and this is C2 center. By using these two centers, we can complete a half circle. Now place a pointer at C1 point, take this radius in your compass, and draw a 1/4 arc. Now place a pointer at C2 and complete a next 1/4 arc. Now we have completed the front view profile. This profile we can see in the front side. Now look at the top view. In the top view we can see this T-shaped profile, and this T-shaped profile is symmetrical, and this profile starts from 2 to 3. This is point number 3. This point number is 2. This is 3 dash. This is 2 dash. The 3 dash line distance is 60 mm. So add this ruler along V direction and draw a line passing through point 3 along y axis. This is 3. This is 3 dash. Now similarly, you can see here from 2, this total distance is 60. 60 minus 30. 60 minus 30, 30, and this rectangular this line distance is 15 mm, 15 mm. 30 divided by 2, this is 15 mm. This is also 15 mm. So along 2, we can draw a line, but the distance is 15 mm from the both side. 15 mm. This is 15 mm. Now from these points, these end points, we can draw a line along the width side. Now we have completed the T-shaped profile in the top view. Now same T-shaped profile in the front side, in this side, in the right left side. We can, the dimension is again same. The height is 30 mm. It is a ruler along height or z axis. The height of this T section is 30 mm. Edges roller along B direction. This opposite T-shape profile we can see. Now we are going to draw this slant surface, and the surface you can see here. If you join these 2 points, we will get a slant surface. You can see here this T-shape profile, and the opposite T-shape profile we get here in the side view plane. This is top view, this is side view. Now at the back side, you can see here at the back side there is a slot of distance at 20 mm. So from this point, this is point number 5, 5, and this is 5 dash. In between 5 dash, this is 5, and 5 dash is 60 mm from front face. This total distance is 60 mm. In between 5 dash, there is a gap of 20 mm. So we can add this roller along B direction, and we can draw a 50 mm, 60 mm line, because width of this object is 60 mm. And from this endpoint, we can directly draw a line up to 3 dash. In this gap, the slot is there. So this, the total thickness is 60 mm. 60 minus 20, 40. So this distance is 20. This is also 20. 20 into 3, 60. So from this 5 point and 5 dash point, we can mark 20 and 20 mm points, equidistance point. Then you can see this is 5 A, B, C, D. So we have joined 5 to A. This is point number 5A. This is 5D. 5D. This is 5 dash D, and this is 5A. Now draw AB and CD. ABC distance is 30 mm, and this is along the length direction. You can see here. And there is a vertical line, and vertical line is up to the base. So we have completed our problem. You can see here, this is 20, 20, 20, and the slot is 30 mm, but in the isometric view you cannot see this 30 mm distance. This is a 3D view. Now those lines are visible, dark, all these lines. So without eraser you can solve this problem. This is very, very simple problem. Now this is a final solution of this problem. Now one more line is missing. So this is a half circular hole. It is throughout, means from this face to this end face, this is a circular hole. So to show the depth, so by using this line we can show the depth of this circular hole. Now the last topic is the dimensions. So give the overall dimensions of this problem. So this is a 100 mm distance. This is 100 mm. This height is 30 mm. So give the align dimension, because this is a isometric view. This is 30. This is 20. This is 30. Total height is 50 mm, and width is 60 mm. Width of the object is 60 mm. This distance is also 30, 30. This is 30, this is 30. Now see the solution of this problem. This is x direction. If we look this object from x direction, we get a front view, and in the front view we can see this profile. And if you look this object from top, we'll get this profile. So just compare the problem and solution, solution and problem. Thanks for watching this video. Try to solve this problem.